So the first number is in degrees. So 40 degrees, negative 40 degrees. So it has a resolution of 256 encoder counts per 90 degrees. Today we're going to be making a position, essentially modifying this servo motor so that we have position feedback to an Arduino using interrupt pins. So here's the hardware portion of the modification. So this is a Savox Black Edition. There's multiple different Black Editions with different specifications of the torque specs as well as the speed of how fast the servo rotates. But today we're going to be using this servo. You are going to need this servo, some heat shrink tubing, and some extremely thin wire, and some headers. These are right angle headers, but you can use any type of headers that fit on your application. So yeah. I don't recommend any thicker than however thick this wire is. This wire seems to be about 0.75 millimeters thick, whatever gauge wire that is. So step one, by the way, once you do this modification, voids all warranties, and if you break it, it's not my fault. So the first step is to remove the 4 bottom screws. So here, take these screws out. These screws go all the way through the entire housing. The servo will no longer be waterproof after this modification. You're going to need a Phillips head screwdriver, a cutting tool, cutting knife, and a soldering iron, which I'm going to start heating up right now. So once you take off these 4 screws, you can just lift the bottom case right off, and we've got a good look at the electronics inside here. So let me put this into some helping hands. Okay. So the pins that we will be focusing on are these pins right here. There's 6 pins. There's 1, 2, 3, 4, 5, 6. Now, these pins are the encoder pins for the brushless motor that the servo works on. These 3 are the phases for the brushless motor, and these are the encoders. If you wanted to modify this servo to be continuous, you could attach an ESC with for brushless, remove all the gears inside, and then just solder and remove these control boards and just solder to these 3 points over here, and you can actually use this as a continuous servo as well. But that would ruin the point of buying such an expensive servo. You're going to also need some wire strippers as well. These wires are fairly thin gauge, so I recommend having extreme care when trying to strip the wires down. So I'm stripping the wires off camera right now. We just get a little bit exposed. Of each wire. Alright, so there we go. So a little bit of each wire exposed. Actually, that was a terrible job. Let me get that off here. There we go. Here we have our wire. Before we even mess with soldering on that, you're going to want to tin the wires. This is really important with really any soldering. Make sure not to clamp the wire too close to the clip, or else you will deform the plastic on that. And get some solder here, and my soldering iron. we can just go straight at it. So what I do is I tin the wire, and then after tinning the wire, I use some clippers and clip it shorter to the amount of exposed wire that I want. That's pretty good. So I'm going to do that again for my blue as well as green wire. So here's the exposed end. Make sure the wire is like straight. So when we cut it, we know the dimensions of a straight wire. And take the soldering iron again. Get that back in focus. Now, a little bit of solder and trim. Here's the last green wire. A little bit of solder and trim. Okay, now that we have the ends of our wires soldered and tinned, it's really important that they're not too long, because as you can see here, the places that we're soldering are extremely small. So it's really important that we do not leave too much wire on this, or we will short the inside out. There is some clear coat or something that makes it more waterproof, but the soldering iron can just melt straight through that, and that's not really a problem. So so there's 6 pins, which is exactly the same as any standard brushless motor. So if we censored brushless motor. So if we look here on this one, there are 6 pins. Now the order of the pins, I believe, are ground, no connect, then phase 1, or no, it's ground, temp, encoder phase A, B, C, then VN, which is in this case roughly, I think the servo voltage, which is 5 volts for this censored portion. And the censored portion runs off of 5 volts. But since we don't need to actually wire all of these pins, we only need to wire the 3 phases, because the ground and power is taken through the standard servo cable. So this servo will still work completely normally without a without the encoder pins plugged in, and it'll work just as it did originally, but now it has additional feedback. So the 3 pins that we will be soldering to are the 3. So there's 1 pin here, which is VN, which is 5 volts. Then there's ground over here, then temp. Then so it's these 3 pins right here. So to do this, I'm going to first add a little additional solder to each point, and afterwards I'm going to hold the wire and try to get it into place. So I'm going to do one at a time here, extremely carefully. So there's 1, there's 2, and that last one, a little trick, 3. Okay. Now the colors don't really matter, as long as you remember how they were ordered inside of here. So another thing is, if you stick the wire up like this, the wire is actually going to interfere with the case. So to do this as best as possible, I recommend taking the end of the wire, and taking a pair of tweezers, if you have some, or you can use your fingers or whatever tool you have. And we're just going to bend this just a little bit so that it's a little easier to solder. So here you can see a little 90-degree bend here. And I'm going to have the wires exit the case near the servo, the original three PWM cable. So what I like to do is I have a little dab of solder on the end of my iron, because this is very small. We don't need much solder at all. I'm going to just add a little dab of solder. And I am going, whoops, that's the wrong end. The wire. Sorry, the camera is just making this very difficult. Alright. So here we go. I'm going to solder the first wire, which is the green one. And that's it. There's one cable. So now we have to do this for 3 cables. So let me get a little bit more solder on here. And it's important to clean the tip between every step. If you don't, you're not going to have clean solder. So clean the tip. I should have bent this initially first. So I'm going to bend this back into the correct format. So some difficulty there. So here we go. It's not a great, but decent bend. Okay. And this one is going to be my far cable. Or actually, I'm going to do the blue one next. I want the blue one in the middle, just from personal preference. Inside of the servo, there's not enough space to actually put any heat shrink tubing. So it's really important that you get the cables trimmed to the right length. So I'm going to need to clean this tip again, add a little bit, just a really small dab of solder on the end of the tip there. Now, here, let me turn this way. There we go. So I'm going to then take the cable and then as carefully as I can get it on there. And solder. And just give it a little tug. This is fragile. You can add a dab of hot glue to make it a little stronger. So here's the red one. I'm going to clean the tip. Add a little bit of solder. Okay. And here's the last cable. This cable will be the one next to the blue one. Here we go. And just like that, boom, we have successfully soldered the servo. So now what we want to do is we want to route these cables in a way that so the cables do not get crushed. So I route the red one to the side over here. Then the blue and the green one are actually closer to the far side from me. So I will be orientating the cable like so. Now, one thing that I like to do is if you have an oscilloscope, now is the time to test the output of these wires to make sure that everything is all hunky-dory. So I'm going to set this aside for now, and we're going to go back to the bottom case here. Now the case fits on in one orientation. You can just remove those 4 screws. Now the easy way to tell the orientation of the case is one side of the case has a circular indent with this B lettering, and then one side is a flat side. The circular side is going to go on the side where the opposite side from where the output of the servo shaft is, because this is where the brushless motor sits. So since we're not doing any soldering, I'm going to remove that from there. And so as you can see here, this round area fits inside here. So when I close this case, there's nowhere for the wires to go. So there's two options. One, you can cut this wire, this waterproof grommet, or you can cut the bottom case. I prefer cutting the bottom case, so I'm gonna grab a cutting tool. And so I cut the opposite side from where the brushless motor sits. So just a very small indentation on the side. Note, before you do this, take this you need to take this wire grommet off, or else you will be cutting that, which is not very helpful. So here we are going to take this and just give it a little cut here, a little cut here, and then just use some form of tool to pull that out. So we have a little slot in there where the wires can pass out of. So now we can just put these cables through that hole we just made, and then take our rubber grommet. Hold on. I'm going to pass these cables through the grommet first. Here we go. Pass the wires through this grommet. And then fold the wires back to how I just had them. Okay. It's a little tedious, but once you get it on, it shouldn't be that difficult. And so now you can just route the grommet into its slots. And once you're done, the servo should be easy to put together, and you just screw it in. And if you're having clearance issues like me right now, you're gonna need to make sure that it's not hitting this chip in the middle. So just pushing on the side a little bit, bang, boom, and we can just, whoops, let's pass all those cables back out of this hole properly. Let me see. There we go. And I'm going to take these 4 screws. One, 2. Since you're threading into plastic, always thread backwards, then screw it in. So once you feel it like in the original threads, then you can thread them in, or else you're going to strip the threads in the servo. This is really helpful if you want to use these servos for gimbals, camera gimbals, since you can get encoder feedback on position feedback. And you don't have to drive the motors with the included PWM, which is handy, but you don't have to. A lot of ESCs, this is essentially an ESC though. It's not really a servo at this point. If you do see some bulge like this, that's fine. But if you want to get rid of that, you have to scrape the inside of it from the additional wires, add a little bit inside. So now we're going to take all the wires and we're going to pull them together. We're going to cut it to the length that we desire. So this is a little long. This wire is a little long. So I am going to pull the wires taut. Alright. And I'm going to cut them all to the same length. And then I'm going to strip them and solder them to the headers. So let me strip these wires. So here's 1, 2, oops, that's really short. 3, And let's give the, oops, I'm sorry, I went way out of focus here. Let me back the camera out just a little bit. Let's do 4. All right, wires are now stripped. There we go. All the same length. All right. Okay. Now again, when you're soldering these tiny wires, I highly recommend that you tin everything before you actually solder them to the thing that you desire to solder them to. It's just a good practice to do so. Tinning the wires beforehand makes soldering a lot easier. You're not constantly pushing more and more solder to where you need it. So I'm gonna clean the tip, and I'm just gonna solder these tips and quickly get the camera to focus there on my hand. Alright, so there's 1, there's 2, there's 3. Alright. So this is perfect length. We don't need to do anything more than this. I'm going to take my my heat shrink tubing and give it a little snip. So here's 1. So here's the blue one. Just push it all the way down. Here's some red heat shrink tubing going in here, like so. And then here is a green one. So we're gonna fix this like so. All right. Now the order that we put everything in was green, green, red, blue. It's just easier that way when you have phases A, B, and C all lined up together. So we're just gonna have it in that same order inside. So it doesn't matter what order you get it into. It just matters that that they're all essentially in the correct order. The color doesn't matter, but just get it in the right order. It'll just make everything a lot easier when you're programming as well, when the phases are in line. So here we go. We have our header mounted inside of here. We're just going to do one at a time. So let me tin these headers really quickly. Let's get this in focus. 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 Come on. Come on. There we go. All right. So I'm going to tin the top of this. So this is, for me, this is an Arduino, for an Arduino do. So here we go. Here's another, and here's, so all these have been tinned. Whoops. All right. And we don't really need to add more solder. So it was red, blue, I'm sorry, was it, I think it was red, blue, then green. So we're going to do the red on here. Red. This camera really doesn't want to focus, I'm sorry. Come on, focus. All right. I'm gonna add a little solder. This one's a little barren. So it's red. Blue. And green. Sorry, these solder joints are absolute crap. Because, so there we go. Camera's in the way. So then we will put this heat shrink tubing on. little bit of heat. All right. And there we go. So now that we have this, we now can use interrupts on Arduino code to get the position of this servo motor. So there you go. Thanks for watching.